love the chase and the hunt, and I set the pace when I'm running. I always...
Namaste friends. So today in the entire Python family, this is chapter 72, and in the NumPy this is chapter 31. In the previous lecture we saw about the introduction of universal function, and we also heard what a universal law means, like this traffic signal red and stuff of that nature. All the distributions are over, and with this universal functions, like the chapters, like I think it will be like a 10 to 12 module. We should also be completing NumPy, but I'm thinking whether to have quizzes, some kind of quick recaps and stuff of that nature. I'm just thinking, since it has been quite a long exercise, and since it will be going up to like 44 days or 45 days, I'm just thinking, so that is with me, but I'll come back to you. So in the last lecture we saw about the introduction of universal function. Okay, so what is universal function and how it is actually helping in the vectorization, how it actually speeds up the CPU, how the iterative can be avoided, and what are all the functionalities that this actually gives to make it better. So in this video, what we are going to be seeing is how do we actually create a function in the universal function. So that is what we'll be doing it. So how to create your own function. Okay, to create your own universal function, you have to define a function like you do with a normal function, which you've already done in the Python. Okay, then you add it to your NumPy universal function library, because from there only you actually call with the from py func, from pyfunc, which is a function, open close parenthesis method. The from pyfunc method takes the following arguments. It takes in 3 arguments. One, it takes a function, it takes the inputs, and then it gives the outputs. The inputs is a number of input arrays, and the output is a number of output arrays, and this is the name of the function. All right, so 3 arguments. So let's actually try this. So when you actually try this, so let's actually see this, and let's actually see how it works. So when you import a NumPy SMP, and then when you actually add x comma y, when you return this x plus y, and then when you actually say, so this is what we are doing, right? This is how we actually create from pyfc. When you say my add 2 comma 1, so basically you're just adding 2 plus 1 here. And then what we're actually saying is, print this my add these 2 arrays. So let's actually see what kind of result it actually gives. It gives us 5 plus 1 6, 6 plus 2 8, 7 plus 3 10, 8 plus 4 12. So this is what actually gives us, because this is what we're actually printing. So we are actually returning x plus y. So this is the amount of input. Okay, so 2 is the amount of input that we've actually taken, 1 and 2, and we are returning 1 output. This is the argument, and we are returning this. And my add is a function. So this actually takes in 3 parameters. So one is a function, one is an input, and the other is output, and that is exactly what we did, and we showed the answer. All right, super. Let's actually move on to the other one. Now if you want to check if a function is a U function, okay, if you want to check the type of a function, to check whether it is a universal function or not, it should return a class numpy.ufunction. Okay, so let's actually take this, because sometimes you want to actually check this. So let's actually take this. So in this case we actually do this, and we actually say, give me what is the type of this. Okay, give me what is the type of this add. Let me see what this is a U function. It says this is a U function. So this is a clear-cut example that this is a U function. Now if it is not a U function, the way it would actually proceed is, if you actually see this, it is a function. It is just a normal function. Okay, this is not a U function, this is a normal function. This is not a universal function, this is a normal function. All right, very nice. If you want to see the function is not recognized at all, it will return an error. So if this, in this case, like add, concatenate and stuff of that nature, what is this blah blah blah? This blah 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 is just like, we actually talking nonsense, right? So if you actually return this, it will actually return an error, which is exactly what it is going to do right now, because this is just not recognized, and that is exactly what I'm actually trying to say. So now if you want to test a function, whether it's a U function in an if statement, then then we actually we use the NumPy U function value or NumPy, alias for the NumPy. So let's actually see, and let's actually go over this code, and let's actually see what is actually happening. So we import NumPy as NumPy. If type np.add equals this equals this NumPy of U function, then print add as a new function, else print it as a not a new function. This is very simple, right? If then else loop, which we have actually done many a times. So by now you guys should be knowing it, so I don't see a problem here. All right, so this is what add we actually saw it as a U function, so it should be giving us a U function. So let's actually see, yes, add is a U function because this is what we are actually printing. All right, so I trust in this U function lecture you have actually understood how to create a function, how to check whether it is a U function, and how to actually go your way, whether to check whether it's a U function or not, how to determine and stuff of that nature. I trust you have actually enjoyed this lecture and probably understood. If you have any questions, kindly contact me. I'll actually try to explain to the best of my abilities. Like always, I like to thank two persons. One is you for giving me a golden time, and the other is my wife Jayashree for allowing me to follow my passion. Till we see next time, thank you, take care, and cheers.